Imagine me and you, I do. I think about you day and night. It's only right to think about the girl you love and hold her tight.
Welcome to Crazy Carrot Studios. My name is James, and today we will be going over making our game object move. Alright, continuing where we left off. In the last episode we set up this scene here. I want to start by setting up my orientation so we can properly represent what the game object is actually doing. Now, if you look at the transform component, if we try to move the cube along the x-axis, which should be to the right and left, you will notice that when we do it, it's moving forwards and back. This is because our scene view is facing the wrong direction. Now, yours may not be in this particular case, but this is how we can fix it if it is. By pressing the right mouse button, we can rotate in the scene, and pressing the middle mouse button, we can pan. Now we want to orient our scene so that the cube's red arrow, which is the x-axis, is facing the right, which represents the positive direction. Now the arrow you see on the cube is representing the game object's orientation, while the gizmo in the upper right is representing the scene's orientation. We want to get our scene gizmo to be oriented in the same as our game object. Now I'm going to move away from the cube to show you how you can find your game object if you get lost in your scene. If you click on the game object and move the cursor to the scene view, then you can press F for focus. This will focus in on the game object that you are looking for. Now let's go ahead and get ourselves reoriented again so that we are facing the right direction. Okay, now that we have the arrows facing the same direction as our gizmos, the next thing we want to do is make sure our camera is set up correctly. If you go to your game view, you may notice it is oriented differently. This won't be the case for everyone. In my case, it is properly aligned, so I'll move my scene view to a different angle and dock my game view so we can see both. And notice the scene view now is different than the game view. Luckily for us, Unity has made it easy for us to solve this issue. Now what we can do is find the view we are looking for, go to the main camera, game object in the hierarchy, and click on it. Then in the top left, look for game object and click. Then towards the bottom you will see align with view. This will have the camera align itself to the scene view, and since the game view sees what the camera is looking at, we now see the same view in both. Next, I'm going to retitle our cube game object to the name Bob. This is going to represent our character that we are going to try to move. Now, I'm going to go down here in the bottom to our scripts folder and hit Create C# Script to attach this to Bob. We're going to call it Move, as that is exactly what we're going to try to do with our game object Bob. So once it gets done compiling, I'm going to just drag that straight onto Bob, and we will see the script is now here. Actually, I have two of them. We'll remove one of those. And we're going to open up our move script. Let's give it a little bit of a space so we can put it in our variables. Let's start off with what is called a vector 3, or unit vector. We've got it assigned to the 0, 0, 0, which is our x, y, z values. Now these values can easily control the length of the vector with a float value. When you change the x value to 1, you're essentially moving the game object to the x value in the positive 1 direction. Next, we want to represent it by multiplying by time, which is represented by time.delta time. Let me go over and explain exactly what that's going to do. Alright, let's start by adding in our public function, our public variable, which we're going to have it as a float, and we're going to title it speed. You can title it distance or anything you like, whatever makes you feel comfortable to understand exactly what it's going to be doing. We are going to give it a value of 1, and then in the start, just to show you how this is going to look like, we're going to do transform.position, because what you're doing is coming to your transform and changing the position. Now you will notice, because our position is 0.5 and we are setting a new vector 3, actually I want to show you without the speed there, and it's set at 100, what's going to happen is when we go ahead and press play on this, I'm going to go ahead and save it and just add this to it. And you can see we got our speed variable right there as well. When I hit play, it's going to jump, but it's going to go halfway down because we need to set that vector Y position to stay the same because we're creating a new vector 3. So in that particular case, you would do something like this. And you always put the F when you're doing the decimal. And then when you come back in here, when we hit play, it's going to jump over and stay above ground. Now, if you notice here, when we zoom in a little bit, our cube is represented by 1 meter squared. Our grid is done by the same way. So that when you hit play, it will literally move over 1 unit, which is 1 meter. Let's take a look and see what that looks like. Now you notice it did move over the 1 meter, and that's exactly what we wanted it to do. Now, if we were to change that vector to 2, you would see it go over one more spot. Now, Unity does give us some predefined values that makes this a little bit easier for us to maneuver different objects by using these keywords. Let's go over what that looks like. Back in our script here again, let's go ahead and take this and let's do a transform dot translate. Of course, it helps if I can actually spell today, which is normally a problem for me. I got my slight dyslexia there. Transfrom.translate. Now, translate basically stands for move into position. So what we're going to do is we're going to move the position to a vector 3 right. Now, essentially, this is going to move it 1 unit to the right. So let's take a look and see how that does after we save it. Let's go into Unity after this compiles and press play. Now it should essentially do the same thing we did a moment ago. We're moving it to the right 1 unit. Now the thing about this is, if we were to take this same code and let's cut it and put it in the update, this is going to update it 1 meter per frame at roughly 60 frames per second. So when we do this, it's going to move so fast you will not be able to see a whole lot of this. Let me go ahead and make sure we've got this in here. Let's pull back because we're going to be able to see this move so fast and hit play. Now you see how fast that moved off the screen. You don't even have time to really get a glimpse at it. So what we're going to do is we're going to change this value to operate under our speed variable that we set earlier, which was called speed. So in this particular case, we're going to come down here and multiply the right by speed. Now remember, speed is the variable we set at the very top of the script when we first created it, right here. Now from here, we're also going to multiply by times.delta time. Now, what this is going to do is now, with the update doing it once per frame, this is now going to make it work by time. Using time.delta time is Unity's way of converting to real time. We are multiplying our movement by real time, which now makes the player move 1 meter per second rather than 1 meter per frame. And you'll notice that we did not have to change anything on the Y. It keeps it in the same position because it's not making a new vector 3. It's moving or translating the vector 3 we already had. Now to take this one step further, when we hit play again, and you go over to your speed and let's change that variable, you'll notice that your speed picks up. And if we go in the negative direction, we can actually bring it back. And that's how the speed will actually manipulate what you're trying to do with the vector 3. Now lastly, let's bring this back full circle and create our own function. We're going to call it private MovingObject. Again, you can title them whatever you'd like. This is just something so that you understand exactly what you're trying to do inside the function. I need to put the void in there. That's always very important. I don't know why I didn't. And we're going to cut this entire code and put it inside our own function. Now, in the update function, we're going to call our function so that it can at least be fired off by something. Now, I can do this in start or update, and it'll run everything inside of our brackets. Now you'll notice that the IntelliSense is already telling me what I need to do. You've got to end it with the parentheses and the semicolon. So now, whether I put that in start or put it in object, it's going to fire off our function and run the exact same thing. Now obviously to start, it's going to run it one time, and in update, it'll do it once per frame or per second based on our time.delta time. So let's save that, see how that looks. And let's hit play. And you see it's doing exactly what we told it to do. And that's going to conclude this episode. In the next episode, we're going to go over rotation. In the meantime, see if you can't go through your own code and duplicate our movement function with a rotate function. A good tool is this Unity documentation that they provide that will allow you to take a look and see how rotation is being done. It is okay if you're not able to do this. We will go over it again in the next episode. And from all of us at Crazy Carrot Studios, we would like to say thank you. And don't forget to please like and subscribe. We will see you next time when we get back to Learning with Bob.